Welcome to Breaking News to Trading Moves.
Glad to be here.
You are tuning in because you want to know exactly what is happening in the market, right?
Yeah, exactly.
And my goal today is simply to talk to you about a specific headline that just dropped and then go over the market winners and losers.
Keep it strictly to the facts, basically.
Right. No exaggerations, just the actual market reactions.
Mm.
We're going to look at the mechanics of the trade and the companies involved.
Which is really the only way to evaluate this stuff.
For sure. So here is the core news we are analyzing. Micron Technology is planning a second manufacturing facility in Taiwan at its newly acquired Tongluo site.
Right, the Tongluo expansion.
Yeah. And the stated goal of this new facility is to expand the production of leading-edge DRAM, specifically including high-bandwidth memory, or HBM, to support AI demand.
Which is a very big deal for the hardware space.
Oh, absolutely. And to set the timeline right from the start, construction is scheduled to begin by the end of Micron's fiscal 2026.
Yeah, and that timeline, it's a crucial piece of information for any market participant out there.
Why is that?
Well, by noting that construction begins at the end of their fiscal 2026, we establish a really calm, factual baseline for our discussion.
Right. It's not happening tomorrow.
Exactly. We are looking at a measured, long-term capital allocation plan here. I mean, this is a multi-year physical build-out rather than, some overnight adjustment to their output.
Okay, so before we get into the specific stock tickers and the winners and losers, we need to establish exactly what this headline tells the market about AI memory demand.
Yeah, the broader market signal.
Right, so what does this actually tell us?
Well, to understand the market signal, we have to look at how critical high-bandwidth memory has become to the AI hardware stack.
It's basically essential, right?
It's an absolute requirement. Like, if you are building data center GPUs and advanced AI servers, you cannot skip HBM.
Because of the processing speed.
Yeah. It is the memory that sits physically adjacent to the processor to feed it data at lightning speed.
Oh, wow. Okay.
So, by deciding to expand fabrication capacity in Taiwan specifically for this technology, management is sending a clear, auditable message to the market.
Which is that they see durable demand.
Precisely. They are saying this is a sustained requirement for advanced memory, not just a short-lived spike in transient orders.
I mean, I want to focus on that specific decision-making process for a second because it reveals a lot about their internal forecasting.
It really does.
Like, why commit to building a brand new facility instead of just running the current ones hotter?
Right, just cranking up the dials.
Exactly. Because to visualize this, if an airline sees a sudden spike in travel demand for a holiday weekend, they don't buy a brand new fleet of aircraft.
No, of course not.
They just fly their existing planes more frequently, or they add a night shift, they add routes. Deciding to pour concrete and build an entirely new fabrication plant proves they are betting on long-term volume.
That airline comparison is spot on. It highlights the capital expenditure reality perfectly.
Right, because adding an extra flight is just operations.
Yeah, it's an operational decision to handle a temporary backlog. Building a new fabrication plant, or a fab, is a multi-billion-dollar capital expenditure.
Billions. With a B.
Exactly. It requires years of planning, environmental approvals, water rights negotiations.
Right, fabs use a lot of water.
Tons of it. Plus power grid allocations and highly specialized equipment sourcing. You just do not pour concrete unless your internal forecasting models show that the demand for high bandwidth memory will remain robust for years to come.
Makes total sense.
And, a modern fab requires specialized clean rooms designed specifically for the vertical stacking processes used in HBM.
So you can't just repurpose an old building.
No, you cannot easily retrofit a 20-year-old facility to do this work. That is the durable demand signal investors are picking up on right now.
Okay, so that structural reality transitions us directly from the decision to build a fab to the actual companies that will profit from making the memory and supplying the tools to build it.
Right, the actual market movers.
Let's start with the memory and storage details. The direct headline winner here is obviously Micron Technology, MU.
Yeah, MU is the direct beneficiary because the expansion is tied strictly to their leading-edge DRAM and HBM supply.
They are the ones actually securing the real estate.
Securing the real estate, planning the capacity, all of that. But we also have to look at Western Digital, WDDC.
Wait, let's pause there for a second. Western Digital is not a DRAM producer like Micron, right?
Correct. They are focused on NAND flash and hard drives.
So why would a company making long-term storage drives move alongside a company making short-term processing memory. Those are two entirely different physical components.
Well, there are different components, sure, but they are bought for the exact same server racks.
Oh, I see.
Think about the architecture of an AI data center. The processor performs the calculations. The high bandwidth memory feeds the immediate data into that processor.
Right.
But where does that data come from in the first place?
The hard drives.
Exactly. AI models train on petabytes of text, images, and video. All of that underlying data has to be stored locally on high-speed, enterprise-grade NAND flash drives.
So you can't just upgrade one half of the system.
No, you cannot have a high-functioning AI server with blazing fast processing memory, but sluggish, outdated storage drives. The system would bottleneck immediately.
Right. The processor would just sit there waiting.
Yeah. So when stronger AI-related memory demand lifts sentiment, it elevates the entire storage ecosystem.
Investors kind of bundle them together.
They do. Investors looking for exposure to the broader data infrastructure build-out will consistently allocate capital to WDC alongside MU.
Okay, that mechanical relationship really clarifies why the capital flows into both simultaneously. Now let's move down the chain to the semiconductor equipment details.
The tool makers.
Right. A new factory needs incredibly specialized tools.
Yep.
The companies listed here are Applied Materials, AMAT,
Yep.
Lam Research, LRCX, and KLA Corporation, KLAC.
And these three are among the strongest sympathy move groups tied to this news.
Why is that?
Because a new fab expansion requires heavy spending on highly specific, really complex tools. We're talking about deposition equipment.
Deposition equipment.
Yeah, which layers materials onto silicon wafers at the atomic level. And we're talking about etch equipment, which carves out the microscopic pathways for the electrical currents.
Wow, atomic level.
It's wild technology. And then you also have process control and yield management systems.
From companies like KLAC.
Exactly. Which ensure that these billions of microscopic components actually function flawlessly.
And high bandwidth memory is notoriously difficult to manufacture, right? It isn't just a standard chip.
Precisely. HBM involved taking multiple individual memory chips and stacking them vertically.
Like floors in a skyscraper.
Exactly like that. But to connect those floors, manufacturers use something called through-silicon vias, or TSVs.
Okay, what are those?
These are microscopic vertical tunnels drilled straight through the silicon and then filled with copper to allow electrical signals to travel up and down the stack.
So they literally drill through the chip.
Yeah. Drilling and filling those vertical tunnels requires extremely specialized etching and deposition tools. AMAT, LRCX, and KLAC sell the exact tools needed to execute those precise manufacturing steps.
You know, I always look at the equipment makers when fab news drops. It reminds me of the aerospace industry.
Oh, how so?
Well, when Boeing or Airbus announces a massive new jet program, the most reliable winners aren't always the airlines buying the planes.
Oh, right.
The reliable winners are the companies manufacturing the highly specialized titanium fasteners and custom composite materials required to build the wings.
That makes a lot of sense.
Right. These equipment makers basically get paid to supply the foundational manufacturing technology, regardless of the end consumer buying the final product.
That is a highly accurate way to view the supply chain. Because, whether a specific AI software application succeeds or fails in the consumer market, the physical data center still needs to be built.
The shovels in the gold rush.
Exactly. The memory needs to be manufactured to train the models, and the fab needs the deposition and etch tools from AMAT and LRCX to actually make that memory. They provide the foundational manufacturing layer.
Okay, so moving down that supply chain, now that we know who makes the memory and who makes the manufacturing machines, who actually needs this HBM to make their end products work?
The buyers.
Right. Let's look at the AI infrastructure and data center chips. The details here point to NVIDIA, NVDA, Broadcom, AVGO, and Marvell Technology, MRVL.
Yeah, NVIDIA is the absolute clearest read-through in this group.
Because of their GPUs.
Exactly. Their AI GPUs depend entirely on high-performance memory to function. An advanced graphics processing unit can perform calculations at just an astonishing rate.
Right, they are incredibly fast.
But it faces a physical limitation known as the memory wall.
The memory wall.
Yeah. The processor is often just waiting idle because standard memory cannot feed it data fast enough. That's the exact bottleneck HBM eliminates.
Let's expand on that physical limitation for you listening. Standard DRAM is used in almost every computer on the planet.
Everywhere, yeah.
Why does an AI processor specifically require the vertical stacking of HBM? Is it kind of like, well, think of putting a massive, powerful engine in a sports car, but you have a tiny fuel line.
Oh, yeah.
And the engine just stalls out because it can't get enough fuel. Is standard memory just limited by the physical distance it sits from the processor on the motherboard?
Physical distance is a major factor, along with thermal constraints and pin counts.
Okay.
If you use standard memory, the data has to travel all the way across the motherboard to reach the processor.
Which takes time.
At the speeds AI operates, that tiny physical distance introduces latency. It also requires more power to push the signal that far, which generates excess heat.
Oh, and heat is the enemy of a data center.
Exactly. So high bandwidth memory solves this by sitting on the exact same physical package as the GPU. The data travels a fraction of a millimeter.
Like a wider, incredibly short fuel line.
Yes. It acts as an ultra-wide, incredibly short data pathway. Without the HBM from a company like MU, the GPU from NVDA simply cannot reach its stated performance metrics.
So the memory supply is quite literally the governor on the speed of the processor ecosystem.
Absolutely.
What about Broadcom, AVGO, and Marvell, MRVL? They don't make the core GPUs.
They don't, but they provide the essential networking and custom silicon.
To connect everything together.
Right. A single GPU cannot train a modern AI model alone. You need tens of thousands of them working in parallel across a massive data center.
Oh, wow, tens of thousands.
Yeah. Broadcom and Marvell designed the advanced networking chips and optical interconnects that allow these individual servers to talk to each other.
I see.
When a company like Micron commits billions to more memory capacity, it proves to the broader market that the entire AI hardware cycle, including the networking required to connect those servers, is expanding.
Makes sense. So we have covered the company's position to benefit. Now we need to look at the other side of the trade.
The losers.
Right, because if specialized memory is taking at manufacturing capacity, standard memory capacity gets squeezed. We are pivoting to the hardware buyers facing pricing pressure.
It's a zero-sum game in manufacturing sometimes.
Let's look at the PC and enterprise hardware details. The companies listed here are HP Inc., HPQ, and Dell Technologies, DELL.
The mechanics here come down to global manufacturing capacity and the bill of materials for consumer goods.
What do you mean by that?
Well, if advanced DRAM pricing stays firm because the supply chain is aggressively prioritizing high-value AI memory, standard memory capacity remains constrained.
Because they only have so many wafers.
Exactly. A fab only has a finite number of wafers it can process per month. If more wafers are dedicated to HBM, fewer wafers are dedicated to standard DDR5 memory used in laptops and office desktops.
And that tight supply forces standard memory prices up across the board.
Yes. Companies relying on lower margin end markets, like standard PCs or traditional enterprise servers, face a difficult mathematical reality.
Because they buy so much of it.
Right. HPQ and DELL have to procure millions of memory components to build their products. If their input costs go up by even a moderate percentage, their profit margins compress.
They just get squeezed.
They operate in a highly competitive market where it is notoriously difficult to pass sudden component cost increases onto the final buyer of just, a standard office laptop.
That makes total sense. Now that brings us to the consumer electronics details. The names here are Apple, AAPL, and Sony Group, SONY.
Right.
But I have to push back on this categorization a bit.
Okay, let's hear it.
Apple commands absolute premium pricing. They have a massive cash pile. Sony sells consoles that people will happily wait on back order for months to receive.
True.
They use custom silicon, like Apple's M-series chips, which utilize unified memory architectures. How could they possibly be viewed as losers just because a memory facility is being built in Taiwan?
Your point regarding their premium brand positioning is completely valid.
Yeah.
But we have to evaluate how Wall Street models component procurement.
Okay, walk me through that.
Yes, Apple uses unified memory in their custom silicon, but they still have to buy the underlying raw DRAM to build that unified memory package.
Oh, right. They don't fabricate the memory themselves.
No, they don't. AAPL and SONY procure massive global volumes of memory across smartphones, tablets, gaming consoles, and smart home devices.
But surely Apple can just absorb a minor cost increase or, I don't know, pass a $5 price hike onto an iPhone buyer without losing a single sale.
They can pass the cost along eventually, but market traders operate on quarterly margin expectations.
A short-term view.
Exactly. Traders look at gross margin expansion versus contraction. If memory costs rise and Apple chooses to absorb it, their gross margin drops by 50 or 100 basis points.
Oh, it adds up.
On a volume of over 200 million iPhones a year, a tiny margin compression equates to hundreds of millions of dollars in lost operating profit.
Wow, okay.
Even if they do not lose business overnight from this one headline, Institutional investors see their near-term financial modeling as less attractive. A tight memory pricing environment always transfers pricing leverage away from the hardware buyers and hands it back to the suppliers.
So Wall Street isn't saying Apple is suddenly a bad company.
Not at all.
They are saying that the variable cost of producing their goods just became slightly more unpredictable, making the stock less attractive for a short-term trade compared to the memory suppliers themselves.
Exactly the distinction. It is a debate about margin leverage. Right now, the leverage resides with the memory manufacturers, not the consumer electronics buyers.
Got it. Okay, let's transition to the final group facing headwinds. We are moving from companies getting hit by actual physical procurement costs to companies getting hit by investor attention moving elsewhere.
The capital rotation.
Right. We are looking at capital rotation in non-AI semiconductors. The details here point to Texas Instruments, TXN, Analog Devices, ADI, and ON Semiconductor, ON.
This specific dynamic is a classic characteristic of momentum-driven markets. Capital rotates aggressively toward the most direct beneficiaries of a capital expenditure cycle.
Makes sense.
TXN, ADI, and ON are exceptionally well-established companies. They produce essential analog chips, microcontrollers, and power management integrated circuits.
For what kinds of products?
For automotive manufacturing, industrial robotics, broad-based consumer electronics, you name it.
But those chips have absolutely nothing to do with training a large language model.
Correct. They are completely insulated from the HBM ecosystem.
So why are they losing out?
Well, when portfolio managers and retail investors see undeniable momentum in AI infrastructure, they face a mandate to generate yield. Institutional money managers often have a fixed percentage of their portfolio allocated to the semiconductor sector.
Oh, I see.
If they want to increase their weighting in MU or NVDA to capture the AI growth, they physically have to sell their positions in broader semiconductor names to free up the capital.
The mechanics of index funds and portfolio weighting really drive this behavior.
They really do.
It reminds me of the capital rotations we saw during the early 2010s with the smartphone supercycle. You know, like being a great acoustic band playing at a music festival, but everyone is running to the main stage to see the electronic DJ.
That is a perfect analogy.
You had companies making perfectly functional chips for desktop computers or networking gear, but their stocks languished for years because every available investment dollar was chasing the companies building mobile processors.
That historical comparison is spot on. The underlying businesses of TXN or ADI did not suddenly degrade because Micron is expanding a fab in Tongluo.
Right, they are still making money.
Their factories will still run, their automotive clients will still buy their power management chips. However, these stocks underperformed the broader sector in the immediate aftermath because they lack direct exposure to the hottest part of the semiconductor cycle.
It's just a math.
Yeah. The financial market is ultimately a mechanism of opportunity cost. If an institutional investor believes the AI memory cycle offers a faster, more reliable return on capital over the next 24 months, they will systematically reduce their exposure to industrial analog chips to fund their AI infrastructure positions.
The opportunity cost aspect really clarifies why a stock might drop or trade flat even without any negative news concerning its own internal operations. It is just capital actively seeking a more aggressive growth vehicle.
That's all it is.
So we have mapped out the entire mechanical landscape here for you, from the raw materials and atomic level manufacturing tools to the direct beneficiaries feeding the data center processors, and finally the hardware vendors and broader chip makers that might face margin headwinds or simply lose the spotlight.
It functions as a complete interconnected ecosystem.
It really does.
When you introduce a massive new variable like a commitment to build a dedicated advanced memory facility, the entire supply chain is forced to recalibrate its pricing expectations, its operating margins, and its capital allocation strategies.
We have looked at the factory timeline targeting the end of the highly specialized tool makers like AMAT supplying the deposition gear, the advanced GPU makers like NVDA utilizing the resulting memory, and the PC makers like DELL dealing with the underlying component costs.
It's a lot to process, but as we conclude this analysis of the market mechanics, I want to leave you with a closing thought to mull over regarding the long-term hardware landscape.
Sure, let's hear it.
We talked extensively about how tight memory pricing impacts large, well-capitalized hardware buyers like AEPL and SONY.
We did, yeah.
The crucial question is How long will consumer hardware giants be willing to absorb tight memory pricing and unpredictable supply cycles before they are forced to either permanently raise baseline prices for everyday buyers or attempt to fund and manufacture their own proprietary memory alternatives?
This is not financial advice or buy or sell recommendations. This is purely the opinion of the author.